Okay guys, so today we're going to learn what an imaginary number is and how to add to imaginary numbers. So typically imaginary numbers are denoted by z, and the representation is by saying z equals x plus yi, where x and y exists in the reals. This new placeholder that we've brought in is a special unit called I, which is equal to the square root of -1. So if we want to add to imaginary numbers, let's first write them symbolically, that z1 is equal to x1 plus y1i, and z2 is equal to x2 plus y2i. So if we add these, you add them very similar to adding vectors. So x1 plus z2 is equal to the two real parts of the number, which is x1 plus x2, and the second part is the addition of the real numbers that are attached to the I, y1 plus y2. So if we go down further to an example, if we say that z1 equals 1 plus I and z2 equals 2 plus 2i, then z3 equals z1 plus z2, which 1 plus 2, those two real numbers, is equal to 3, and the two numbers on the I, which is 1, and then plus 2, which is 3i. So if you graph this on the plane, we would call this the complex plane, where now your y-axis is complex numbers, and your x-axis is R numbers. That's why it's typically denoted x plus yi, because the coefficient of x is on the x-axis and the coefficient of y is on the y-axis. So if we graph this, it will be a point in space, which we can draw to as a vector. And the same way for the other vector, it's a little bit bigger, obviously. So you do that, and then what we can expect, just like vectors, is that when you add these together, you add them from tip to tail, which that's basically what our addition is doing, just breaking the vectors into their, well, you can see complex numbers analogous to vectors, but they're not totally vectors, but just adding the components in the different directions, the complex direction and the real direction. And from that, what we get is we get a bigger vector, and with that will end this video on adding complex numbers.